Hello children, welcome to Yamuna's physics classes. Today we have to discuss the topic 14.10 of the electronics or semiconductors, chapter 14. And this is a very interesting and quite simple topic known as logic gates. In school, in home at all, we have seen gates. What do you mean by gates? Lot many people entering, lot many people going out, right? So that's the use of a gate. And at home, too many people are not coming, like school or a public space. Maybe the number will be reduced. But few are coming, few are going, right? So logic gate is again a gate itself, where so many people are entering, but the condition is only one can go out. Any number can enter, but only a single person can leave. That is a basic idea of a logic gate. Moreover, logic gate is the building block of the entire digital world. And digital world recognizes only two numbers. You may be clear, 1 and zeros. So digital world is a world of 1 and zeros, or the binary number system. You have different kinds of decimal system, binary, hexadecimal, decimal. Decimal is the ordinary number system. 0 plus 9 people joined together form 10 people. That is decimal. Deci means 10. 0, the rest 9 people are known as decimal. Similarly, there is a binary system just working with two numbers, 1 0, 1 0, nobody else. And George Boole was a scientist who did Boolean Algebra in the year 1847, 100 years back of independence. So at the time itself, he created all the rules, regulations for working with these two people. What are they? 1 and 0. 1 refers to high, 0 refers to low. Means like bulb switch on and off. On means there is light, off means no light. Tap is on, you have water. Tap is off, no water. So that's option. Either there is yes or no, true or false, correct? And here the signals you are using is also a digital signal. Digital in the sense, usually we have studied in rectifiers, AC, sinusoidal or cosine wave. All are curves which is analog. Every second the values are changing. But in digital world, we have only square waves. Square means it's just like a step. High, low, high, low, high, low. That kind of steps you have. So it's like a square pulse going on. Square means here you have high, then coming low. Again high, low. So that is a method of a square wave. In that square wave, any positive values refers to 1. Suppose you have a 10 volt, 20 volt, 50 volt, that is referred as 1. You don't have any volt, 0. So binary number system is the basics of Boolean algebra. And digital system all working under logic gates. So logic gates are building blocks of digital world. Home, a school, whatever construction, it starts from a small brick. You start from a brick, you multiply it and make it different forms. So the building block is a simple brick. Similarly, all the binary system has the block as it starts with logic gates. Clear? So we have three basic gates. Fundamental, we have studied fundamental quantity, derived quantity. In lesson 1 itself, class 11. So we have come across units, fundamental quantities, derived quantities. Similarly, these three, or, and not, are named as basic gates. Rest of the gates are derived from these people. So or, and, not, the three fundamental gates. Whereas nor and Nand are derived gates. You have again other more gates, but we are discussing just 5 of them. Clear? Okay. So this is a meaning. If any of the input is high, the output is high. Meaning, I can give you a small example. Suppose myself, my name is Yamuna. I wear a sari. If these two options are correct, give full mark. That is one option. And another option is, if any of the two is correct, give full mark. It's a question, right? So, I am saying myself, I am Yamuna, I am wearing churidar. But even then, or kurta, something else. But even then it is correct because the option is or. My name is Yamuna, that is correct. My dress, I say pants, jeans, something else. Even then it is correct. Why? The option is or. So any of the inputs, one input is my name, other input is my dress. Whatever apparel I am using, whether it is any one is correct, any of the input is correct, give a high. Means the output is high. So you can have any number of inputs, just one output. I told you logic gate means there is a particular gate where anybody can enter but only one can leave. Clear? So A and B, two input gates. But you can have any number of inputs. Suppose it is you are using two inputs, the possibilities are 2 to the power 1. Means, 2 to the power 2 means 2 square, 4. 4 options you can have. So if you look at the columns, A and B are written the same manner. Because if it is 2, everywhere I have used 2 inputs. Means if it is 2 input, the options are 2 square. Because you have only binary. So the options is 2 square. So the options for A are A 0 0, A 1 1. At the time B is toggling. If it is 0 0, B has 2 options. Again if it is 1, B has 2 options. So these are the columns. A and B will be exactly the same except for this. I will say the rest, whatever gates you have, if it is a 2 input gate, this is the only option. A and B. A and B shows input and Y shows output. Clear? Okay. Now this is the Boolean algebra you are going to use. Y is found like A or B. Similar to addition but not exactly similar. Somewhat okay. See, if A and B are 0, 0 plus 1 is 0, right? 0 and 1 add, you get 1. 1 and 0 added, you will get 1. Again 1 and 1 added, you won't get 2. That is a problem. 1 and 1 means both inputs are high, so output has to be high. That is a rule. So that is a OR gate. OR gate means any of the A is high, you have a high. Any of the B is high, you have a high. See, here B is high, yes, okay. Here A is high, yes, okay. Here A and B are high, okay, no problem. So that is OR gate. Clear? It is again read as A or B. A and B are inputs, Y the output. Clear? Now come to AND. Again the same question. Myself Yamuna, I wear sari. No other options is marked. You can say whatever options other than that. Only if these two is correct, you can give the full mark. Means you have only 2 options. So 2 options I have given. A, myself Yamuna. B, I wear a sari. Both are correct, give full mark. Otherwise no. Otherwise no. If any one of the answer is correct, no marking, 0 0 marks. So the answer is here only. This is myself Yamuna. This is I wear a sari. Both are correct, give 1. The other options are extremely wrong, no marking. 0. Maybe 1 will be correct. My name is Yamuna, I wear churidar. My name is Jack, I wear sari. So it's not okay. Both should be correct, right? So that is known as AND. AND is A and B. Don't take it as dot. Similar to multiplication but not exactly multiplication. Here 0 into 0, 0. 0 into 1, 0. 1 into 0, 0. 1 into 1 is 1. But may not be always. So this is somewhat like multiplication. This is somewhat like addition. Not perfectly, right? Okay. So it is read as A dot B. No, never. Read as A and B. It's not dot product, cross product, nothing like that. It is A and B. Now, this is a unique gate. Very unique. Meaning only one input, one output. Rest of the gates you have any number of inputs, one output. But for NOT, only one input, one output. Clear? So if only there is one input, how many options? 2 to the power 1, that is 2 options. What are they? 0 and 1. And whatever you give at the input, it gets the NOT, produces inverted version. What do you meaning by inverted version? Inverted means what? It gets inverted. 0 means toggle to 1. 1 means toggle to 0. Getting the reverse. So, duty of NOT is to reverse whatever you are getting. You are getting 1, 0, then you give 1. Entering person 0, coming out 1. Entering person 1, coming out 0. That's the only one logic gate which has single input, single output. So, this is known as a single input gate. All other has values other than 1. Clear? Okay. So, these three are known as fundamental gates or basic gates. Basic or fundamental gates. The rest of the people are derived from the basic gates. So, as the word suggesting, the name suggesting, you can understand. I have written in the same colors. Not and or. Which is not? This is not. Which is or? This is or. Put together you will get nor. Very simple. Not and or gives you nor. But you have to make sure that the bubble identifies a NOT gate. You have same triangle for a diode, for a Zener diode and all. But the bubble has to be distinguished, or identification mark of a NOT gate is a bubble, not the triangle. So wherever you see a bubble, make sure there is a NOT operation. So here the bubble is placed at the output, not at the input. The bubble I can place here also. Here means input is bubbling or inverting. But here the answer is you have to bubble at the output. So this is the portion. Up to this, you know, it is A or B. Up to this portion, it is A or B. Then you have to bubble. Means what? To take the Y or output, you should take A or B bar. So up to this table, this column, 1, 2, 3 columns are exactly same as OR. Same thing. OR is recreated here. A, B, A or B. In the last column only, I have given the complement, transpose or whatever you say, bar it, toggle it, means 0, 1, 1, 0, 1, 0, 1, 0. Means whatever you have for A or B, take the reverse, that is reversing or inverting. Inverting option is A or B bar. Clear? So what is NOR? OR gate with a NOT at the output. Make sure it is at the output. Similarly, what will be NAND then? NAND is not and. See, N of the not and written. Not and. So what is not and? The and, the table yellow, same thing reproduced here. A dot B. Up to this, it is an AND gate. Once you get A dot B, A and B. You should write A and B. Once you get A and B, then give a bubble. Here itself, it is A and B with a bubble. It is A and B bar. A and B bar. That is, all the 3 zeros goes to 1, 1 goes to 0. So, hope it is clear. You have 5 gates. 3 the fundamental, 2 the derived. Basic gates, what are they? OR and NOT. What are the derived one? NOR, NAND. 5 fingers, 5 gates. Hope it is clear. Okay, you can have a screenshot, write down, learn it now itself. Very simple topic and a sure question for the paper.